Okay. Good afternoon to the local public and greetings to those who are from the center and south of Mexico. I'm architect Noe Villa of Arq MXL Team Coordinator. We are a group of young architects who are in search of improving the urban quality of our city and doing activities to help us grow as professionals. After pausing for a month and as part of the activities we are organizing, today we come back with our Arq Talks 2020, which have the purpose to inform about the professional work from different architects to the youngest ones, with the goal of acquiring more knowledge through their experience and continue updating ourselves. Today, we count with the participation of Arq Pritchard from Air Inc. He has a Bachelor of Science in Design Architectural Studies, a Master of Architecture, and a Master of Urban Design from the Arizona State University. As a faculty associate at ASU, he has taught undergraduate and graduate studio courses, including Design Fundamentals 3 and Architectural Studio 1, 2, and 4, for example. He has worked in Middles Tagliabue EMVT Architects in Spain, in Tomcat Design in Arizona, in Studio 121 in New York, and since 2016, he joined the Air team as a project architect. Founded in 2001, Air Architecture Infrastructure Research Inc. is an architecture and urban design firm focused in translating advanced research methods and sustainable practices into elegant design solutions that respond to each client's particular needs and desires. The firm sees the complex contemporary environmental context of each site as an opportunity for investigation and unique solutions. Before starting, we want to say that in our 2019 Bahart conference cycle, we had the participation of AIR with the presence of architect Darren Petrucci, AIR's founder and director, beginning with the celebration of our Colegio de Arquitectos Mexicali 50th anniversary. Welcome, Mr. Pritchard. The microphone is all yours.
Muchas gracias por la invitación para hablar con todos ustedes hoy. Desafortunadamente, mi castellano no es bueno, pero espero que la arquitectura pueda compensarlo. So, for the rest of the talk, it'll be in English. So let's, hold on. There we go. Okay. So I'm going to start kind of a more focused view of just a comparison between Mexicali, or a study between Mexicali and Phoenix, and how we share very similar geographic, ecological constraints. And then I'm going to zoom kind of back out to where we can get to more of a conceptual understanding of where our office is coming from. So you can all hopefully recognize the desert area here, the Gulf of California, the Pacific Ocean, Mexicali, and Phoenix. They're locations within the Sonoran Desert, how unlike the Mojave or other deserts in North America, we share the exact same desert, same flora and fauna. I think the uniqueness too of what we deal with as cities is tied to water and our adjacency to water and our ability to function as cities with water. And this will get into a larger discussion that I'll talk about with the role of technology and how we view technology in the desert. So technology allows us to live in the desert by being able to harness water amongst other technologies, especially more recently with air conditioning, things like that. So you can see, especially within the Phoenix area, we have three primary rivers, I guess I'll call them, the Rio Salado, the Gila, and the Agua Fria. But especially the Rio Salado has been heavily dammed in the past decades. So you see, the locations of water to the east, to the west. We have farmland out in areas like Buckeye, where irrigation is allowing those things to happen, but primarily within the Phoenix metro area where urban growth has happened exponentially over the past decades. A lot of those waterways have been dammed or just basically dry, but a lot of our city is still kind of built around that. And then the connection of those things like the Rio Salado down to places like Yuma, and then ultimately down into the Gulf. But looking at the primary metropolitan areas, with Phoenix, you can see we're constrained by the mountain ranges, by the Native American reservations that are surrounding the area. And then some, like the rivers are a way of kind of dividing some of those areas. I wanted to note too that the ability to harness the water in our metropolitan region has allowed us to have a nuclear power plant, the Palo Verde nuclear power plant, which is one of the only nuclear power plants in the world that isn't located next to a major substantial body of water that would be used to cool it. And so we've taken water from various places around the city and found a way to function and cool a nuclear power plant. So the history of the place that we live, the canal systems, the waterways, still plays a hugely important role of the technology that we currently live with in our city. So I'll zoom back out, looking at the global scale. The work that we've done in our office, we've done projects, completed or are working currently on projects in Arizona, in Phoenix, primarily the Phoenix metropolitan region, in Portal, Arizona, which is near the border to the south, in Massachusetts on Martha's Vineyard, and then project we are currently working on right now in Cape Town, South Africa, which, interestingly enough, has a similar latitude south of the equator as Phoenix is north of the equator. So we found it in our solar analysis, our studies of the ability of tracking the sun. It's extremely similar to Phoenix. Obviously, the climate is a lot different, and the relationship of the sun being in the northern part of the sky versus the southern part of the sky is also different. So this is a diagram that we use, or the beginning of a diagram, to talk about the conceptual framework of where we're coming from and how technology and architecture have evolved primarily since the 1960s, I guess, in a sense, starting in the 60s as the beginning of it until now. So beginning in 1969 with Apollo 11, man landed on the moon. And this obviously was a seminal event in the course of the century, but it demonstrated how people with a clear vision can overcome and surmount vast obstacles through technology and determination to achieve those things. And so we talk about, how the President Kennedy championed this idea in the early 60s to land man on the moon before the decade was over. And the vision of this dream was achievable, not because it was a call to arms against an enemy, but because it was a dream. It was a really radical, fundamental dream of humanity to understand the universe and to understand this object that we've been familiar with, the moon, throughout our entire history. And so it was a dream that pushed the limits of technology and illustrated that there's a kind of a marriage between the necessity of technology and the dream of technology, the narrative of technology, in order to achieve these really incredible things. But taking that on as a primary technological social or cultural achievement. Looking at architecture specifically, there are these movements within architecture that occur every 10 years or so that are reflective of manifestos and changes that happen. And so we'll look at some of those changes, some of those key points in the decades that occurred after the moon landing. So with the moon landing in the 60s, there was an inspiration to an architectural movement that was called high-tech architecture. So like at the Pompidou Center, Richard Rogers was at piano, the work of Norman Foster at that time, that was both technological in its mode of production, in the way that those things were formulated and came together, but also the signifier, the aesthetic of that technology. And so especially you can see in the Pompidou Center, the aesthetic of the building is the layering of systems and the understanding of the technology that goes into not only support the structure of the building, but support the life and understanding of the spaces within the building. So from that, 10 years later, there was a reaction to the kind of sterility and austereness of high-tech architecture in what Kenneth Frampton called critical regionalism. And he used Alvar Aalto's San Gonzalo Town Hall as an example of this critical regionalist architecture. And according to him, it was an architecture that should create spaces that provide tactile experiences. And so with that, not only the modern understanding of what life is at the time and place, but the materials that are used and the cultural influences of those materials coming together to form a sensibility that is about what life means, not just in a nostalgic sense of traditional architecture, but of modern architecture living in contemporary times, but sensitive to the place. And then 10 years after that, looking at the emergence of global warming and climate change, Jason McClellan guided a research and technology solutions group that turned into the Living Building Challenge. And I'm going to show you later on in this presentation project we're working on that is going for Living Building full certification. So we have a lot to say about this. We have a good understanding about the Living Building Challenge. I think as of today, there are 20-something fully certified living buildings, and most of them are in North America. I believe there's a few maybe in New Zealand and one other country. But on the right, you can see the Bullitt Center in Seattle is by Miller Hall, is kind of emblematic of the result of going for a Living Building Challenge project. But unfortunately, most of those buildings in their rigorous research and development to achieve the constraints, to overcome the constraints and manifest a building that lives up to the Living Building Challenge. Aesthetically, they seem to all fall somewhat short of a sensibility that I guess unlike a critical regionalist building, the Living Building Challenge buildings tend to be almost as sterile as some of the high-tech architecture. They typically highlight the technological strategies as the primary signifiers of their attempt to save energy and end up looking like power plants. So you can see in the Bullitt Center the glorification of the solar panels on the roof, making this large canopy, the use of green elements within the building and plant material. I know in the projects we've been working on, it's been a point to talk about biophilia and psychological understanding and view of how things like the color green in a building can affect the experience, but we want to try to challenge that and kind of go beyond that and find what are the significant factors that can contribute to aesthetically good architecture, rigorous architecture, and technologically rigorous architecture, and functionally rigorous architecture. So we want to have all these things incorporated into one and not just be subservient to specific points in the history of these movements of architecture as they're moving forward. So with the previous attempts to manifest the technology, to aestheticize it, the technology and sustainability were considered failed experiments from which a new integration could be conceived, one that is closer to what Ramon Gutierrez calls an appropriate modernity, but with an integrated technological agenda. So this is kind of our radical dream, is how to integrate the technology of the moonshot with the contextual program pragmatism of a specific place. And so with technological advances in architecture that are critical to our existence on this planet, technology should not be the inspiration for that life, but life should be the inspiration for that technology. So life and nature is an integrated set of systems where function is not just a matter of form, but of beauty and sustainability, a dialectic almost of those things coming together, and they should be seamlessly integrated. So creating a synthesis of those things rather than just having those two exclusive things combined together. So when we approach a project or begin the design process, we look at three different conditions separately and simultaneously. So primarily, we start with a site analysis, but also with a programmatic analysis. So you can see in the upper left, we begin by doing furniture layouts of the different programmatic conditions that are part of the client's brief. And so we basically say, what are your wants and desires for this project? They come back with a list of things, the types of rooms that they want, things they want in those rooms, and then maybe any specific constraints they might have for some of those rooms. And then so we model just those rooms without walls. So we model a floor area so they understand the space that they're working with, and then we show furniture, or in the case of a garage, we'll show a car fitting in there with the garage door as a way for them to understand, all right, these are the constraints that we're working with, and this is an architectural vacuum where we're not designing a building, we're not even really designing the room specifically, we're just showing you what the constraints are based on the program that you've given us. Here's what we think you're talking about, and then we have a back and forth whether or not we agree, and we fine tune those things to focus in on exactly what the client wants and how those spaces basically need to function in order for the client to get what they want, but still devoid of any architecture at this point. It's just a pure analysis of that. And so at the same time, we're looking at the site that those things are taking place on. So we've done a number of projects in Arizona on the hillsides of the surrounding mountain ranges, or the mountain ranges that are within the metropolitan area. And so having constraints of building on a hillside, the types of views that you get from those sites, the logistics of getting material construction, understanding civil engineering at that point, just getting a basic understanding of what needs to go into those things. And then thematically, how do we respond? Is the site oriented for good light orientation? Is it facing west where we need to really mitigate that late afternoon sun in the summer, things like that. So those are all taken into account early on. We look at that independent of program, always understanding, these things are going on simultaneously, but we want to make some very clear suppositions about what the site needs to accommodate based on just the site analysis and not having the architecture influence how we view the site necessarily. So we want to find an idealized understanding of the site that will then inform the architecture. And then we look at the technology and materials that are available in the area and that are appropriate and how they will function over time. And so in the case of Arizona, we build a lot of buildings, houses with wood framing, some steel, a lot of glass. And then we've done a few projects out of concrete masonry block, which is another very common material here. But in the case of our projects in Cape Town, where there is very little, if any, wood frame construction, we are using a precast concrete system, which is still not typical of residential projects out there, but it's not a completely foreign process. This concrete is much more commonly used out there. So we want to have a good understanding of the place and the specificity of materials that are important to that place and that are part of that place. And so over time, as those materials begin to weather and react to the location they're in, it's not going to be a matter of maintenance and constantly repairing and repainting or redoing parts of the project. It has to be something that the aesthetic of the building is its longevity and sustainability and ability to occupy the place that it's in. So those things all simultaneously working together create an overlap where slowly, we begin to narrow our focus down. We're still looking at each one independently or separately, but they start to overlap in their assessments. And then we look to nature and how the systems of nature are a fantastic way to synthesize those three things together to formulate an outcome that is really the idealized version of all those things, where there's an understanding of technology, an understanding of nature, of material, of climate, and then of function. And so we do look at biomimetic responses or biomimetic ways of thinking in order to influence some of the work that we do. So if there's a natural way to shade a building, to cool a space that involves some sort of solar orientation idea, we would rather go that route than trying to artificially cool it with some basically foreign technology. Not to say we don't have air conditioning in our projects, but it's just something that we try to make it basically foolproof and really still have some functionality, even if the specific latest technology wasn't going to be part of that spot. And so, I mean, hopefully you've seen on our website, we tend to aestheticize this space program astronaut idea as a way of saying that our projects are part of an environment, especially in the Sonoran Desert here, that can be inhospitable, like space. And so with the help of technology, we're able to function and live through it. And I wanted to bring up too that, this, even in the midst of a pandemic, the technology of a face mask is so important and consequential to how we can still function and connect as a society. So I think that understanding of we still live with technological constraints all the time, and even the face mask is part of the technology that allows us to live through the moment that we're currently in right now. But that is part of a larger understanding of the fact that I'm talking to you over Zoom, over the internet. Technology has allowed us to really function in a way right now that wouldn't have been possible years ago, even though things like the face mask are still and have always been relevant during times of pandemic like this. So that's where this idea comes from, where the stars in the sky, the moon is kind of this overwhelming part of understanding that the desert is just underneath all this vastness, and the technology of space is analogous to how we approach the design of our projects. So I'm going to start to talk about some of the work that we've done, and I'm going to talk about 3 projects in the Phoenix metro area. So right now, I'm going to quickly just point out this is kind of the outline of the overall area. There's some mountain ranges in the middle of the metro area here, the Phoenix Mountain Preserve, Camelback Mountain, and Mummy Mountain. You can see the remnants of that waterway that used to come through. This was the Rio Salado. And then this is the canal, infrastructural canal kind of overflow area in the city of Scottsdale. But primarily you have a metropolitan area that is polynodal with Phoenix, Tempe, Mesa, Scottsdale, and Glendale, all these different municipalities that were at one point separated and are now collectively together. So you can see in the middle here, I'm going to talk about the Ghost Wash House, the 4321 house, and the OB1 house. So the 4321 and OB1 were recently finished within the past year. So they haven't been properly photographed yet, but I'm going to show you some of the construction photos of it and some finished photos that we have that I've taken as a way to show some of these projects that we haven't published quite yet. So beginning with the Ghost Wash House, this is a zoomed in area of that Phoenix metro region. This is Camelback Mountain right here. This is what's called the town of Paradise Valley, and then Mummy Mountain up here. And the project itself is located right here, which is at the base of Camelback. Camelback is a popular hiking and resort area in the region. There's a number of resorts, hotels here and here, and then some very nice single-family houses in this area. And so the primary views in this case, with north being up, are this way towards Mummy Mountain, and then back up the mountain of Camelback to the south. And you'll see images of how those things are working with the orientation of the building. So looking closely at an aerial view, you see there's basically 3 distinct bars of the building, and then one large mass here, which is a roof canopy. So this is our kind of conceptual drawing describing the elements of the project. So in this case, north would be to the lower right. You see the 3 bars. You see 1, 2, 3, and the 2 bars on the side are brick masses. And then through the middle of the house is somewhat of an infrastructural landscape where you have planters, you have the public spaces of the house, you have more planters, water gardens, grass, pool, and then a guest house down here. So all those are connected through this area in the middle as a way of flanking what used to be, or what kind of still is, a wash that went through that area. So it's not just the Ghost Wash. The name, I guess, comes from this idea that it's a remnant, or the vision of an idealized wash that is in that area that has now become part of the house. So the conceptual framework begins from these desert images. And so the top image shows a nurse tree, which provides shade and adds moisture and cover to animals that graze, and adds extra nitrogen from leaf litter and bird poop from the branches. So these conditions facilitate the growth of the cactus below the overall canopy here. And then desert wash at the bottom, it captures water, soils, and organic matter from the surrounding landscape. It hosts bigger trees than the surrounding desert can support because it has access to more water. Dry washes occupy less than 5% of the lower Colorado River subdivision of the Sonoran Desert, but hosts 90% of the bird life. So they're important corridors for animal, plant movement, and environment within the Sonoran Desert landscape. So I'm going to start with the images of the house showing this view. This is looking to the north, and you see the large knife edge canopy over the top. But it begins with, it's a brick courtyard surrounded by brick walls, brick planter. This is an 8-foot datum that goes across here. So it's very unassuming in terms of the scale, and you don't really get a sense of what's going on inside except for maybe some of this landscaping that's coming through over the top. But I think this image represents a fundamental idea that we talk about in the office as well, and that's the dialectic between canopy and cave. And I believe this system, or these two ideas, come from the work of John Lautner, the California architect, where there's basically two kinds of residential or sheltering architecture. One would be a canopy, and the other would be a cave, and they're obviously opposite ends of the extreme, but they both provide shelter in their own unique ways. And so while a canopy tends to be more tectonic and additive structure over something, caves are fundamentally stereotomic or carved masses. So in the case of the Ghost Wash House, you have a tectonic canopy that floats over the top of the building, and then these carved heavy masses of brick that are anchored to the ground and carved out of the earth that allow this space of the wash in the middle to function. So looking at just a basic floor plan of the upper level, you can see some of the programs of this entry space where you have the driving courtyard, entry courtyard terrace here, entry doors right here, and then the main public spaces of the house. On the west side, this would be west over here, you have a master suite area, master closet, and then this living sitting area, and then bedrooms and an office space over here, and garages, kitchen, and patio on this side. The lower level has more office space, a gym, wine cellar, and mechanical areas underneath. So you can see through the section of the building, the parking court is over here. Sorry, it's not labeled. The entry courtyard here with the planters, that public space in the middle underneath the canopy, and then how it steps down the landscape down to the pool area, and then the pool house up there. So I wanted to show too, this was an early model that we made of the project almost 10 years ago now, to get a better understanding of the systems that were involved, and just to show kind of the early thinking on the project. So going through the 3 bars of the project, you can see the patio area, space underneath, kitchen, and then the garage area over there. That middle banded landscape that's coming through that is more figured with these curved walls and then these concrete apertures going through. And then this west bar with deep recessed windows on the west side, much more massive part of the building as a way to shield the rest of the building from that low west sun. And then the canopy coming in over the top The canopy not only shades the building, it has solar arrays on it. The configuration is slightly different than what's shown here. And it also, you can see that it comes down into 4 points that land on these 4 parts of the concrete ribbons that form the entry as a way to collect the rainwater from the building. So this is looking from the driveway to the entry. You can see the garage doors right here are hidden by Corten steel clapboards and have edged glass lights on the side. This would be after you come in through the driving court, down that entry procession between the planter and the brick wall. Go through that glass door and you see the patterned brick on the side here. Looking back, you also see up that view, Camelback Mountain. And this is the view looking towards the house from that same courtyard. So that previous view, you're standing right here, looking south. Here you're looking north through the house. You see the floating canopy overhead. These concrete ribbons. These are the steel supports for the roof. And then with the glass itself, you see the reflection of Camelback Mountain in the background, and then Mummy Mountain, which is that mountain to the north in the distance. Another view from the planter itself, looking towards the canopy, you see the lightness of these steel supports that support the roof. The roof itself, where is that? I believe the roof itself is a nearly 100-foot long knife edge, and then these are just 8-inch by 8-inch steel tube columns that support that. And it has a Corten steel cladding on the bottom. You can see the entry door is a 7-foot tall by 10-foot wide central pivot door that when it's closed, there's another parallel concrete frame and door on the north side that defines the living room. So it acts as another part of that piece of glass that encloses the main living areas of the house. So this is the view from inside, looking back at that pivot door, looking back up towards the mountain through that glazing system and through the concrete aperture. Looking down at the public spaces, you can see the glass doors on the left and the right, the wood ceiling that's underneath that large Corten steel canopy. Looking at the dining area and the kitchen, see the clear story glass up above that negotiates the form of the roof with the bars down below and steel that spans between its concrete masses. A view into the kitchen, you can see again through here a view towards Camelback Mountain, and then skylights that are still underneath that large canopy of roof that bring light down into some of these other areas. Same space on the other side of the canopy, again, another skylight through there, and this hallway leads down towards master suite of the house. So those bars are defined by hallways that bring you to the program that flanks sides of the house. So you get, in those cases, some distant views to either landscaping in this case, to mountain views in this case, and how the glass itself, or the masonry walls itself, have glass that separate them from ceiling, where you get these slots of light that can come through and wash the patterned brick on the walls. So you see how tumbled this is. I mean, this feels like it's 2 images collaged together, but it's just one shot of the wall inside and the glass next to it looking out. So you're just seeing an equivalent view that would be of this glass over here, but obviously clear and not edged. Another view up the mountain from the master bedroom. They have a private courtyard space in here that looks up towards the mountain. Master bathroom with a spa area outside here. There's a pivot door that goes out to that area. This is just a patio on the public's bar of the house, north of the garage, that has views out to Mum and Matt, and you can see the guest house down there. If you're looking back up at that patio, you see the landscaping integrated as part of this highly defined wash, architectural wash space in the middle. And if you're looking from the pool house, over the pool, through the landscape, up to the house, and then up to Camelback Mountain. And then looking at the pool house itself, you see reflections in the glass here reflect the aperture, but also reflect the aperture that's up at the main house. And then black spanker glass that clads the sides of privacy, but also reflects the landscape back onto the facade of this house. So it feels still integrated within the landscape that surrounds it. There are two separate offices in the house. One is on the west bar, one is up on the lower level, the east bar. And then kind of the nighttime shot looking back up at the house from the pool house, the edge of the aperture of the pool house on the side there. So this house, it won AIA National Residential Award in 2018 as one of the top, I think there were 5 or 6 houses that the AIA selected in their residential category. So now I'm going to talk about 2 projects that we haven't really talked about too much yet. The 4321 house and the OB1 house, which are, one is located in the Arcadia neighborhood of Phoenix, and the other is in an area of Scottsdale, basically the middle part of Scottsdale. Scottsdale is a long linear city. So this is kind of in the halfway between the top and bottom of Scottsdale. So the primary elements, there's a very similar tectonic system working in both of these projects. So really these, more so than a lot of our other projects, are defined by the relationship of the canopy of the roof to the massing of the volumes below. And so in the case of the 4321 house, which is this one on the left, there's a clear language of this massing as it marches down the facade of the house. The canopy is set back and kind of perched within and on these masses that support the roof. Whereas this is the OB1 house, its primary function as a canopy is to wrap those masses and contain those things within the house. So this is really about the skin wrapping around the house and shielding those things, whereas this one is about the masses occupying the lower level of the house, and the canopy floats above to allow for space, but also for shading around it. So this is the finished 4321 house. Looking from the outside, you can see those white stucco masses. This is unfortunately a west elevation, so it's some difficult sun exposure in the evenings. You can see, and I'll show more of the tectonic system that's supporting this, but it's based on, we looked at some of the case study houses, the Eichler houses, where they had large glulam beams that transferred the loads of the roof across the building. And so with this, we looked at how do we not only create a thin canopy that disperses the weight across the space, but transfers those loads down to larger glulam beams that form a datum across the house, and span across these masses to support the weight of a roof that on the outside it seems very thin, but you can see the thickness of the glulams that it takes to support that weight. So it's about these larger masses in front that protect the building as much as possible from the sun, the western sun, these recessed spaces, and then the large canopy on top that disperses its weight down to those masses. And the glass acts as a negotiator between those systems and fills in those gaps to create a sealed system that's obviously occupiable, but as a way to bring light in and to negotiate the geometries that are different between the massing and the canopy. So beginning in the construction of it, you see how the massing of the building, these low rooms are on the side, and then the canopy itself marches up over the top. And so the glue line beams, you see how they step up on these steel posts. The way that the steel posts work is they have a knife plate in the end, and the glue line beams are cut at the end and then bolted through on the sides. And then that same steel plate, same steel assembly has a shoe or a little saddle on top that supports these thinner beams that extend out to the edges of the roof. So instead of carrying these massive beams out to the end and exposing them, we used them for most of the span that they needed to be used for, and then we added on smaller beams to create the thinness of the structure that you see on the outside. And here you see during construction, the sheathing on the massing parts of the building, the steel supports, and how the roof is carrying and floating over the top. And this would end up becoming the front door right here. See in the kitchen behind it. Again, another view of those steel supports. You can see they haven't been quite calibrated yet, so they're not tuned to be plumb. But how those things sit on top of these transfer beams in the middle span, and then divert the loads down from the smaller beams up top that they're carrying. So here's a view of the finished house. This is that kitchen window we saw from the sheathing earlier. The finished beams above have a light whitewash. The steel columns are exposed. And then just the openness of these spaces, the large kitchen counter infrastructure is running through this soffit over here. So you see the air registers that lead to this area, and then more turbo nozzle air registers that shoot air conditioning out into the space. So we didn't need to clutter the ceiling with a lot of mechanical stuff or a lot of lighting. We try to keep it as clean as possible. So we only have these hanging pendants here that are done at the same datum as the beams, and then a lighting system that's integrated into a steel track that's connected to the sides of the glue lamp, so you don't see the actual lights themselves, but they wash up to the canopy and then reflect back down to the house. You looking in from the outside, you see the connection between the glue lamp beams as they go across and then span over, but also the different systems that are layered throughout the house. So not only a layering of structure, but a layering of these glass systems. So here I'm standing, or the photographer is standing outside the building on a side kind of courtyard, looking through a window system, and then into a living area inside. And then there's another exterior courtyard in the middle here, and then the master bedroom is through another window system over there. So you're looking through two different outdoor spaces and two different indoor spaces as you look through the house. So you can see curtains here, obviously, for privacy in some of those areas, but there's also a visual transparency that connects different spaces of the house and provides opportunities for reflecting the exterior spaces to the inside. So just like we saw in the Ghost Wash house, where we have views back to the mountain there, this specific site doesn't have the benefit of some of those more iconic views, but because of the amount of glass and the reflectivity of the glass in different angles, you're able to see outdoor spaces or connect to the outside from a lot of parts of the house that you might not normally be able to see if it were designed differently. So kind of jumping back, you can see the massing of the house as it steps down. The proportions of each of these volumes are kind of worked out where they have that ratio of 4:3:2:1 as they're counting down, just kind of worked out that way. And so the name kind of stuck from that. But even during the construction, you see clearly how the roof passes over the masses and lands on the middle of the garage area there. But then at night, the house itself, illuminated by those masses, the roof kind of goes away, and you just see these stereotomic forms in the landscape. So this is the OB1 house then. So with this house, you'll see it's a very similar construction system, but we looked at a number of different details in this one that are different than the 4321 house. So first and foremost, you can see this black metal, brake metal covering over this area, this long linear piece, which is covering a glulam beam that's the primary support along the facade. So unlike the previous house, the 4321 house clients wanted to keep the glulam beams exposed. They liked the look of that. We felt with this house, it had a southern exposure. It was going to be best to clad that beam with something so that way the sun wouldn't deteriorate it over time. So in this case, you see metal standing seam skin that comes around and becomes a fascia for the building, but the way it's bent creates a thin edge around here. Again, just like the 4321 house, the windows act as a clear story that negotiate the geometry between the horizontality of the glulam and the canopy of the roof. In this case, the roof is covered in tongue and groove wood boards that are both inside and outside the house that form a continuous skin that extends not only out but then down the sides of the building. You can see the wood down on the side over here. So there are some different structural constraints though for this house. So unlike the previous house had the roof coming down to the masses, so the way we could deal with shear forces in that was a little more straightforward. But in this case, because of the design of this facade, the way to accommodate a shear wall along here, where we have clear story glass right here, was to put a piece of spandrel glass right here and have the shear wall for this side extend all the way up to the roof right here. So this wall, a stucco wall, structurally tied to the glulam beam behind it, and then has sheathing that connects all the way up to the roof framing right here and across. So that way, structurally, it's all connected, but the spandrel glass allows the continuity, the reflection of the light from the outside of the house to maintain across the facade. So this is an early construction photo. Again, you see the same systems at play. Here we had the ability to raise the glulam beams inside the roof assembly a little bit more than the previous house. So they're going to appear more hidden in the final images. The framing comes into the side, steel post, 4-inch by 4-inch steel post supporting the roof, and then going down to transfer beams below. So you get the benefit of the height, but the mass of the structure is dispersed over the whole dimension of the canopy, so you're not trying to beef up something at the very top or at the very bottom. It's spreading out the structural loads across the building. So this is the house with the wood ceiling framed in. You can see up here, there's some reflectivity. It may be hard to tell, you can see in some other photos, but we had some mechanical areas that are above this datum height of the glulam beams, and so we clad those in mirrors. So it reflects the tongue and groove boards over the top and allows that continuity of that material to read across the space, and you're not distracted by other masses that are kind of popping up outside the building. Again, you see the wood coming down across canopy there. This is prior to the outside wall being finished right there, but you see close up that cladding system, brake metal coming down to cover everything. So all the wood cladding behind here is covered to preserve its longevity, but it also maintains the idea that the skin, this delicate wood underneath, is protected by a metal, harsher metal skin on the outside that is more appropriate for the desert landscape. And then just in context, you see, again, this has some views to Camelback Mountain, but because of its location in the neighborhood, can't really see it as well as, you know, some a ghost watch house or something. But you see it's the types of houses that are in the neighborhood right now. This is kind of a mid-century neighborhood where some of these have been remodeled. But the way the scale of them works, it's long and linear, and at the ends it comes down to a height that is analogous to its neighboring houses, but still, because of the framing, allows for vast kind of high ceilings on the inside. So this is one of the finished walls looking at the inside. This steel bars, similar to what we did at the 4321 house with integrated lighting. This is the mirror up above. You see how the beams kind of end. This holds the mechanical area up above here. And then we decided to clad some of these walls in MDF panels. So you have the kitchen over here, and then wall cladding in MDF with specific paint finish to it, where it reads more like cabinetry and less just like a drywall wall. So it feels more like a built-in piece of furniture than just a typical wall that you would find in a building. And then obviously the television, wanting to preserve the aesthetic of the room, hiding that within a black wall so that it doesn't dominate the interior elevations of some of these rooms. This is looking at the other side of that same room, where we wanted some flexibility for these masses that are inside. So you have an MDF wall that has a large movable, basically it's a typical sliding door that you would see on the exterior of the building, but we put one on the inside, tracks along underneath the granite beam and in the concrete floor, so that way this space can be open at one point, or it can be completely closed off. So once that thing is closed, there's a door hidden here that closes and latches into that slider, so that this becomes a completely separate room that can become a bedroom, something like that. So the flexibility of a wall system that is made out of MDF that has these seams can hide things like those doors that you don't want to see all the time, that are part of a larger thinking about these masses, but they're not something that are necessarily everyday functions of the house. And again, because of the geometry of some of these spaces, how would the client say, in this case, black out the master bedroom if they're trying to sleep and there's still some light up? Because we have unusual geometry with the clear story windows, it's difficult to get shades that can cover some of those things. And so the solution was to create this basically wood halo around the master bed, and then have a curtain that encloses that area. So you're just basically enclosing the bed and still allowing the rest of the room to maintain the geometry and lighting conditions that the clear stories afford. So this allowed for a certain amount of flexibility, but also accommodated the needs of the clients to be able to black out the room in order to function better. And again, with the sliding walls, the sliding doors and windows, the reflection in those, allowing different landscape conditions to come from the outside in. This is obviously not the finished landscape quite yet, but the reflectivity in those things too creates perceptions of the space of the room being much larger, much different than what it actually is. And so we found in a lot of projects the expanses of glass not only act as environmental separations between spaces, but they can perceptually pull views, light, and reflections into rooms that wouldn't normally have those things. And so we're trying to figure out a way, like how do we start to anticipate some of these things and start to design for some of these conditions to happen. So we have that intuitively in our mind as we're designing, but it's still something that we come across a lot of, these happy accidents that happen where different rooms are suddenly unfold in a way just due to the reflection of the glass. So this is the view from the other side of that same facade. You see up here, there's a flat area above the garage. The roof comes down here. And so there's an opportunity for a roof deck on this side that would have views out towards Camelback. But the way this is detailed, the tightness of the glass in the clear story you don't read the frames. You just see some of these seams limited by the size of the glass, but we're trying to maintain a kind of hermetic building skin on the outside, and then let the canopy extend out over and protect those areas of the building. So this is a diagram just showing those systems at play in the house. So you have the metal skin, the space for the roof deck over the garage, and the framing, glue beams coming across, transferring the loads, supporting the framing up above, and then how those turn down structurally for shear and support. And then section through the building, you see the glue beams coming through, the masses of the kitchen over here, the sliding wall would be over here in the bedrooms, the mechanical areas are up here, and how those spaces look looking through them, and then cutting through the floor plan, seeing this front courtyard area, the entry, and then the open space in the middle, and then looking through those glass areas to define some of those spaces. So basically with this, you have the front entry here, the living dining area, kitchen, pantry, powder room area over here, a bedroom, Jack and Jill bathroom is behind here, and then another office potential bedroom right here. Then the master suite is back here with master bath right here, and then all garage tandem spot that could eventually turn into another bedroom eventually. So quickly, I'll try to wrap up. We're still determining the nomenclature for this project, but this is what I'm going to show you are the Cape Town projects, or at least one of the projects that we're doing in Cape Town that we tentatively titled Gemini, because in the case of the area, it's a single-family neighborhood that is trying to densify, and so our client tasked us with creating duplexes, and so in that sense, we have these twins within the building unit itself, but also we're doing two projects relatively close to one another, same program, same client, same building systems, but they're radically different in terms of their form. So they're twins in that sense also. So that's where the kind of thinking comes through with that. But to kind of familiarize yourself with the geography of the Cape of Good Hope in Cape Town, you have the main city center right here on the north side of the Cape. Table Mountain, which you'll see pictures of, is right here. It's a very iconic, emblematic image of the city. You have these vast areas of flatland that contain mostly the townships and the lower income levels, and then some scattered cities across the Cape as it extends down to the Cape of Good Hope here. But you have the Atlantic Ocean on this side, you have Table Bay up here, and then False Bay over here. This is all Atlantic Ocean water. And then there's mountainous regions over here, wine growing regions. But primarily the historical city center and the primary city center of Cape Town is located right here, right off of Table Bay. So our site is located right here, right next to Table Mountain, right next to the central business district of Cape Town. So this is a view from, there's basically 5 or 6 iconic geographic points within Cape Town. So this is taken from one of those points looking at the others. So this is standing on a place called Signal Hill, looking towards Table Mountain and Devil's Peak over here. You see the kind of city bowl. To the left is where you would get the main central business district of Cape Town. Some historic areas over here, and then the older single-family neighborhoods would be located right here. And so, sorry for the blurry imagery. You can see our site is here, Table Mountain, here, Devil's Peak, looking to the city center, looking to Signal Hill, looking to Lion's Head, another iconic part of the city. But basically, our projects are located right at the base of the natural preserve for Table Mountain. So all this area up here is basically nature preserve. It's just sometimes forest fires or brush fires that go through there. And they try to limit the spread of those through from the natural areas into the city, but it's a constantly regenerating landscape. It's got unique flora and fauna, and it's one of, just the Cape itself has its own class or category of flora that are only found there and nowhere else in the entire world. And even Table Mountain has endemic plant species that only grow on Table Mountain. So it's a very unique natural landscape, and we tried to look at some of that as we were designing projects. So during the most days in Cape Town, it might start out fairly clear, but then over the course of the day, you get these accumulation of clouds that come in over the top of Table Mountain, over Devil's Peak, and they call it, not ironically, the tablecloth that comes over the top. And so the way the cloud systems function and are part of this constantly evolving landscape, something that we looked at in thinking and design of our precast concrete systems for the project. So looking at the geology, looking at the natural landscapes, and how could we design a system that could integrate views and relationship to the site, the same way the clouds do, but then structurally be enough to span and create open and viable spaces below, but also accommodate things like solar panels that could sit on top of there, or collect rainwater for purposes of rainwater harvesting. Cape Town is going through, or has been going through, a significant drought in the past, and so that's an important part of it. But not only on top of that, I forgot to mention that this is these projects were going for full Living Building Challenge certification. So with that, the collection of water, the accumulation of solar panels, the understanding of its relationship to the landscape is hugely important for that aspect also. So with this, I'm just basically going to show the drawings for one of the projects. We took that thinking for the roof system, which would be these beams here, and looked at how we can take the same formwork and design a column system as well that could clad the outside of the project. So these are also part of the same formal system that supports the canopy, or the concrete, precast concrete beams up above. So we have these every so often to support the structural load of the building with slot windows on the side. The neighbors are very close, and so having these slot windows at angles allows for views and privacy at the same time. But the constraints of building down the side of Table Mountain created this condition where we have 3 separate volumes right here. By zoning, we were required to step down in accordance with the heights that were dictated by the city. So with this, we have a kind of, and to mention too that these are 2 units. So as a duplex, we saw a lot of cases in Cape Town where you'd have 1 unit on top and 1 unit below, but in order to prioritize the views, we wanted to have 2 units side by side that they'd have equivalent views, primarily out towards Table Mountain and then out towards the city center and Table Bay. So these are 2 units side by side, same program. A master bedroom area up here. The entry is kind of below this. You'll see in the section. Entry area with a bedroom on this level, garage underneath. So the driveway comes down, and then you enter the garage down here, and then kitchen living area on this level, and then kind of recreation area, bedrooms, service area down below here. So it's a lot of program that's tightly stacked and then condensed in a narrow band, and then fit side by side to form 2 units. So you can see here the way it steps down. We have a cistern down at the bottom of the swimming pool here, but the main entry would be at this level. You walk across up to get above the garage area, and then enter into the building here. then descend down a series of stairs. You can't see it in this section, but behind the garage here, you would descend down a stair to get to the main living area. Or if you're coming in for daily, groceries, things like that, you pull in the garage and then just walk right through the kitchen. But you have master area up here, bedroom, closet, bathroom. Bathroom has views up towards Table Mountain. But then also a patio up here with views out to the city center. See the beams as they march down. Clear story windows also up here, so you get views from inside here through the building up towards Table Mountain. So at the bottom area, we just have shown one side of the project. The program is mirrored on both sides, but we have outdoor patio, swimming pool, recreation area, bedroom, bathroom, servants, caretaker room, laundry, and then a mechanical area, and then opportunity for an elevator here, which acts as the main structural support for the master bedroom area up above. Again, you see the driveways coming down into the garages, entry, pantry, kitchen, dining, and then living area here, which has expansive glass that looks out towards the city and Cable Bay. This is all with north to the right, by the way. And then, so this is the entry level up above, up a ramp to the main door of the house, bedroom with bathroom, suite, patio, and then stairs that would take you down to the main kitchen areas of the house below. And then this stair would go up to the master bedroom area up above, to the master suite with the closet, bathroom, and patio. And then you can see the solar panels on top, and then water collection goes out to the sides of the building into the precast walls, and then down through rain leaders into the cistern below. Section through the circulation, you can see it's really complex in terms of circulation. It took a lot of time to really work through all these things because we have ramps to the garage, to get to the garage down to the street. We have stairs up to the different levels of the house. It takes up a lot of space within a narrow footprint. And then some things like the living area is slightly lower than the dining area in order to accommodate views over the top. The recreation area is slightly lower than the bedroom area next to it. So this has stairs here, ramps up. Again, another ramp up to this level, just as a way of negotiating the height constraints we had and then the length restraints we had, but then also incorporating an elevator into the building for accessibility as part of the living building challenge. So all these things are accessible. We have obviously ramps on here to get to the elevator on this side. These spaces can get to ramp up to the elevator, etc. So every space is accessible by a ramp. This is a preliminary rendering looking at the entry from the main street. The reflection in the glass would be up towards Table Mountain in the background, and then these two spaces up here are for the master bathroom, etched glass below and clear glass above. The design of this is somewhat tweaked since we've made this rendering, but fundamentally it is the same. You see the entry ramp up here, you enter over here. This is shown a configuration where the garage gate off the street is open, so you can see that, and then the main door of the house here. And then you see the volumes as they step down over the garage. And then view from the kitchen, looking out towards Table Bay and the city. These precast concrete beams spanning across, providing that just formal resemblance to the clouds, but also allowing for clear story views back up through them. So they collect water, provide solar panels, but hide the solar panels and allow you to get light and views throughout the space. Another view. You see the curvature of these columns over here that exactly the same as these roof beams. they're the same form that's just been turned down through the building to create those vertical supports. This would be a view from the patio at the base where by the swimming pool there's a guillotine window that the bottom one comes up, the top one comes down, provides a guardrail at the top and then opening at the bottom to allow for mobility to the outdoor spaces. And then this is the same product, like basically the same program and similar construction system. These beams are the same as the ones here, but we have unique conditions on the side. So it's the same program, but it's a different lot, different configuration, different opportunities for views. So it's a radically different formal strategy, but it's using the same tectonics and has the same program. So I'm going to just quickly end by talking about some of the work that I've done in the studios that I've taught, just as a way of not only talking about practice, but I think the benefit of being part of the university is constantly being able to engage and talk about and discuss ideas of architecture that you might not get to talk about in the office as much. And so I think having connection to the university, both myself and Darren teach at the university. So having that as a way of constantly filtering through ideas and constantly having to grapple with design problems that are outside the scope of normal practice has been hugely beneficial. So two primary areas that I'm focused on in terms of teaching is the idea of scale and composition. And so in this case, this was an early study that when I was in a housing studio, it was co-taught by Victor Irizarry. He developed a exercise where we looked at how the students would composite collages to talk about domesticity and the idea of living and in a way that allowed them to kind of free up preconceptions or just get away from the kind of standard and tired conventions of housing. And so, you know, some students looked at it like, well, maybe there's a series of rooms, a series of windows, but then other students were obviously a lot more playful with how they viewed it. But I think the idea of constantly playing with composition is incredibly important because it influences some decisions you make in the field, building a building and understanding how you might detail something that it needs to not only function and work, but aesthetically how those things come together. And the second thing that I'm really interested in is scale and the idea of how scale can inform so much of architecture. And just like composition, I feel like scale and proportion and composition are some of these tools that we can use that don't cost necessarily a lot of money to play with. Obviously, the bigger things cost more, but there are things you can do with scale and proportion that with slight tweaks can differentiate the work from very conventional means to something really incredible. So in the case of this exercise, I had my students cut out scale figures and then place them within just non-architectural or zoomed in conditions where they had to create a storyboard narrative of the story of what was going on. So I think like in this case, there was like a murder that happened or something. People are talking, but then like a shootout. Like, so they were looking at found spaces within their apartments, within their houses, within the school, and then creating a story that came out of that, but then using composition, composing the photographs, writing a narrative, and then understanding the scale of the people that they were putting into these narratives as a way to really grapple with space and understanding the space, and only using scale figures, not actually producing architecture from scratch. So again, just looking at composition, how an idea for tectonics can come through, an idea for scale can come through. And then this exercise was inspired by an exhibit that Soa Fujimoto did at the Chicago Biennial, where he took found objects and tectonically arranged them and put scale figures in to create spaces. So like he had an example of staples as part of it. I had my students use screws in these cases, 3M tape, binder clips, pipes, things like that, wood shims that allowed them to explore geometries that maybe they weren't familiar with or weren't going to be conventionally derived from Revit or SketchUp or something like that, just as a way of understanding the tectonics of this, or in some cases, the stereoatomics of defining these spaces. And then just looking at how those things have translated into final projects with an understanding of scale and proportion. In this case, this was a housing project. And then this one was a interfaith spiritual center that the student designed to be on ASU campus, representing a view towards one of the desert buttes that we have surrounding the space, but really getting the students to think about scale, the human body's relationship to the space, and really trying to get them into the project in a way that I feel like a lot of even though there's really great things about modern computer programs like Revit and SketchUp or what we use in the office, ArchiCAD, there's still a disconnect between how those things are implemented. And I think until they actually build buildings in the field, this is the next closest approximation for how they can really understand and get a feel for the spaces they create. And that's it. Thank you.
Thank you very much for this, Mr. Pritchard. Do you hear me?
Yes.
Yeah, okay. Thank you very much for this excellent presentation. Now we'll start with the Q&A space. So if you have any question or comment, you are free to turn on your microphone or to write it in the comments. First of all, we have a comment from Arturo Nucamendi. He says, thanks, Joe Pritchard from Colegio de Arquitectos Chapanecos, Mexico.
You're welcome.
So, anyone have a question or comments? Well, first I would like to say that I'm a little bit impressed for all the projects you do. And for example, in the first one, in Ghost Wash House, I like the way that you make the clients or the people who live there have the possibility to see everything in the context. So the way you use a lot of windows and higher. So it's very nice the way you can stay there and feel like you are totally in the nature, just like protected in the house. So the views you can see there are amazing. I mean, at least I would like to be there watching all of it.
Well, and I want to say it's a double-edged sword sometimes. And you guys understand this, living in the desert. You can't, if you're outside all day, especially in the summer, you want a nice respite from the heat and the sun. Like if you've been exposed to it for 12 hours, you don't want to come home and just constantly been bombarded by the desert landscape. So having that connection of landscape is important a lot of times of the year, but it's also important to have areas where you can have some refuge from it. And so I think we try to focus on having places where you can rest and be away from all that, but also engage it when you want. So if you can do either or, and so we try to make it the best of both worlds.
Yeah, I know. Here, for example, in Mexicali is almost the same climate than in Arizona. So we understand it 100%. what you are saying about being protected by the climate. Lucia Penelope is asking you, what do you think is different in architectural schools now that you are a professor in comparison from when you were a student?
Well, I think the biggest difference, at least like when I'm old enough to know that when I started, we started with hand drafting with lead pencil on arches, watercolor paper. We did watercolor renderings. We did charcoal renderings. We did pastel renderings, and then slowly transitioned into computer programs. So we started with the old school kind of ways of doing it, and then learned the new ways of doing it. But then at the same time, as we went through school, went to graduate school, we all still continue to work in the studio environment as a way of camaraderie, but also as a way of, it'd be 2 o'clock in the morning and we'd go over to somebody's desk that was still there and we'd just say, hey, what do you think of this? We sketch out things. We go out for drinks or something and sketch out things on napkins. So having that spirit of camaraderie, I think was super important for me or influential for me to stay engaged in school. I think students nowadays have so much other stuff going on that it's hard for them to engage architecture school in that same way. At least I found that in at ASU in the States, where they come to studio, they talk to the professors, they engage with what they have to engage with, and then as soon as class is over, they're out the door. So I guess my not focus, but like something I'm very interested in is not necessarily saying, well, we have to make studio or architecture school the way it was, because it shouldn't always be the same, but how do we redefine the architecture school to accommodate that, but also to still allow them to get the most out of that experience of architecture school.
Okay, perfect, thank you. Edgar Pimienta is asking, does the black color of OB1 house make it warmer than other colors? Can you name the small plants that you use it on OB1 package?
So yeah, the black color when you're inside the house, you have all this wood and then a lot of white, and then you see some of the black on the outside. But the wood, I think, really pops, and the wood feels incredibly warm, especially like in the desert here. You don't really get a lot of exposed wood because it just doesn't last. But to have that wood ceiling on the inside, the wood beams, it feels really soft inside, actually, even though it's this harsh black metal house. And so that metal is just acting like a truly protective skin that's protected from everything else, but then it allows this warmth and softness to the wood to really come through on the inside and to really ensure that it's going to last on the inside. The plants, I'm not too sure exactly. I can look at those. They were just some small ground covered plants. They haven't fully grown out yet, I guess, the way we want them to. So they're still relatively small for what they should be doing. But I can't recall off the top of my head what those plants are. We had a landscape architect on the project that specified a lot of those things, but I'll have to look it up and find out.
Okay, thank you. I hope he got the answer. Yeah, he says thank you. Well, I would like to make a comment. I like the way you use visual transparency between spaces in the same house. At least me, I haven't seen it in another projects because usually they used to build walls between spaces just to separate them. And in your projects, like for example in the second one you project us, it's curious the way you want to communicate the spaces. I mean, it also can be separate, but you have the option to make that visual transparency between them?
Well, it's obviously more expensive to have all that glass in there, but I think the flexibility of it. So whether it's a sliding glass wall or it's a fixed glass wall, but with a curtain in front of it, it still allows for a flexibility of transparency or accessibility to that space. So rather than having trying to do too many gimmicks with a conventional wall, we think having a system like that allows for the maximum flexibility, but also is relatively simple. They're all conventional systems, like sliding glass walls, curtains, all that are nothing special. So just using them in a unique way, I think, is the real benefit.
Yeah, that's very good. Thank you. Well, I have one more question from Camacho. He says, it's really interesting how you are taking on consideration not only the topography of the lands of the project, but its surroundings, considering the landscape and its different elements that contains, like clouds, water, and earth. Like you are considering a particular ecosystem when you are about to intervene on the land. So my question is, if you have any projects or have plans for small pavilions or interactive installations that translate this narrative, because I see there is an interest to teach by models and compositions.
So if you look on our website, we've done a few small projects, and I think smaller than the scale of a house where the program is not a house, but we've done a few that are outdoor pavilions, or we did an installation at a museum in Scottsdale. If you look on our website, there's a project called Flip a Strip that started out as an urban design competition where we looked at an existing strip mall in Scottsdale and then tried to redefine it with an urban design strategy. And then as part of that competition, being invited as a finalist, we were asked to create an installation for the museum that the competition was being run by. And so in that case, we designed a series of a furniture piece that was made out of artificial turf, and then had a cooling, basically like an air conditioning unit inside of it that dispersed cold air throughout the furniture itself. So that was obviously meant to be in a desert environment where you don't want to sit down on a really hot concrete or metal bench, right? So there's stuff like that. There's stuff like the house that we did in Portal, Arizona, near the border with Mexico, is very, very small, very, very tight budget, and it's only used as kind of a weekend retreat house. And so the ability for that house to still want to have glass, but also want to be secure, it has these panels that cover all of the glass parts of the house, so it can be completely enclosed and secure, and then shaded, and then protected for when the client is not there. So I think the idea of looking at smaller spaces like that with very like one key program or something is a really interesting way to experiment with some of these things that we deal with on larger houses. And so we found the other outdoor pavilions or furniture. I mean, we've done bus shelters and things like that too. The cooling strategies, the visual strategies, the functional strategies that we investigate with those things sometimes manifest themselves in the larger houses that we do.
Perfect. Well, Lucia is asking you, well, first of all, Camacho say thank you. And Lucia is asking, how much of your education from your master in urban design has helped you in the practice of architecture?
I mean, so far, primarily, so before I started at AIR, I worked at a number of other offices where we worked with developers around Phoenix, and to really understand where developers are coming from in order to talk with them in a cogent way, I found that the urban design background really helped with that, because they're dealing with larger scale thinking sometimes about, like, if it's a whole, you know, strip mall or something that they have to deal with, how they can parcel out some of those things and understand the relationship of those things, different tenants within their building, how they will all work together. And typically it's not like, well, they're thinking about it that way because they want this to be a really incredible project. They're thinking about the bottom line, how much it's going to cost and how much money can they make from it. But in order for us to take that, get them what they want, but also try to make a great project at the same time, without their necessarily help on it, but give them what they want, but also we have an obligation to help the city. And so I think urban design background is really focused, especially I think me, on every piece of architecture that we do or that I do has to be part of a collective of architecture within a city. And that's a huge responsibility to have, and we have to be aware of it all the time when we're designing something. And so whether or not it's just a high-end single-family house is one thing, but it's going to be part of a neighborhood, which is part of a larger subdivision, which is part of the city. And so taking that all into account, not that it has to be aesthetically the same, but it's part of a larger conversation about what it means to live in that city, especially if it's a house. So I think that's where I've come from in thinking about it, but also, I mean, we've worked on projects that haven't been built necessarily yet that are a much larger scale. And so we've done projects that were, looked at master planning projects that were 600 acres. So just to be able to think about designing something that large requires some experience in dealing with things at an urban scale.
Yeah, perfect. Thank you very much for your answer. If you don't have any other questions or comments, I will gladly say thank you very much to Architect Joe Pritchard for accepting our invitation to participate in this talk. It was a pleasure to have you here and to listen and see a small part of the work you do in Arq and by yourself also. It's really, really fantastic. We also want to give you a virtual thanks. So just let me share it here. Arq MXL coordination. Thanks to Architect Joe Pritchard from Arq for his valuable participation as a conferencist in Arq Talks 2020, an initiative of Arq MXL, which belongs to Colegio de Arquitectos de Mexicali AC, Camaca. July 30, 2020, Mexicali, Baja California. Signed by Architect Juan Gualberto Maya Sobranes, Colegio de Arquitectos de Mexicali's president, and Architect Noé Villa, Arq MXL coordinator. Sorry.
Well, thank you. Yeah, thank you. You're welcome, and thank you for inviting me. It was a pleasure to present this stuff to you guys today.
No, thank you. Thank you very much for accepting to be here. Well, before going, I would like to take a picture of this talk. So we invite you all to turn on your cameras, to take the picture. So, well, I will give you 5 seconds just to turn them in. 5, 4, 3, 2, 1, 0. Perfect. Well, thank you. Thank you very much. Thank you very much for everyone for joining us today in Arq Talks 2020. We remind you to follow us on Facebook, Instagram, and YouTube, where you can find us as Arq MXL. There you can watch our last talks and be informed about the future ones. And also you can find this talk too. So thank you very much, Mr. Pritchard. It was a pleasure. And thank you very much to everyone. See you in the next time.
Thanks.
Bye.